Good day, students. It's nice having you back in class today. Hope you are keeping safe. My name is Mrs. Fakoya Elizabeth, and I will be your chemistry teacher for today's session. Today, we'll be discussing chlorine as a non-metallic element. Learning objectives for this lesson. At the end of the lesson, learners will be able to 1. Write the electronic configuration of the halogen family. 2. Give the general properties of the halogens. 3. Discuss the occurrence, preparation, properties, and uses of chlorine. Key vocabulary words are displacement reaction, oxidation state, electronegativity, and oxidizing agents. A. Displacement reaction. Displacement reaction is a reaction in which one element replaces another element in a compound. B is oxidation state. Oxidation state is the charge an atom appears to have in a neutral molecule or in an ion. C is electronegativity. This is the power of an atom in a molecule to attract electrons to itself. And D is oxidizing agents. They are electron acceptors. They are substances in which the oxidation number decreases in the positive direction. What is halogen? Halogen is a Greek word meaning salt former. It is the family name of elements in group 7 of the periodic table. The family members are fluorine, chlorine, bromine, iodine, and astatine. Electronic configuration of halogens. The first member of that family is fluorine with atomic number 9, and the configuration is 1s2, 2s2, 2p5. The second member of that family is chlorine with atomic number 17, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p5. The third member of that family is bromine with atomic number 35, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, and 4p5. And the fourth member of that family is iodine with atomic number 53, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, and 5p5. General properties of the halogens. Number 1. They are non-metals. Their atoms have 7 valence electrons. Number 2. They exist as diatomic molecules. F2, Cl2, Br2, and I2. Number 3. They are colored. Fluorine is yellow, chlorine is greenish yellow, bromine is reddish brown, and iodine is black. Number 4. The halogens are highly reactive. Hence, they are never found as free elements in nature. The order of reactivity decreases down the group. That is, fluorine is the most reactive and iodine is the least reactive. Number 5. Fluorine has the smallest atom. It is the most reactive non-metal, being the most highly electronegative and hence the strongest oxidizing agent. Number 6. Their solubility in water decreases from fluorine to iodine. Now to chlorine. Introduction. Chlorine with the symbol Cl is the element below fluorine, F in group 7 of the periodic table. Chlorine is a non-metal. It exists as a gaseous diatomic molecule, Cl2, in which the two atoms are linked by a single covalent bond. Its atom exhibits isotopy. The most abundant isotope, chlorine-35, has a shell structure of 287 and orbital structure of 1s2, 2s2, 2p6, 3s2, and 3p5. After this short break, we are going to look at occurrence of chlorine. Thank you. Welcome back. Occurrence of chlorine. Chlorine, like other halogens, is highly reactive. Hence, it does not exist as a free element in nature. It occurs in great abundance in combination with sodium as sodium chloride in seawater and as rock deposits. Laboratory preparation of chlorine. Chlorine is usually prepared in the laboratory by the oxidation of concentrated hydrochloric acid using strong oxidizing agents such as manganese 4 oxide, lead 4 oxide, or potassium tetraoxomanganate 7. In the setup for the preparation of chlorine gas in the laboratory, we have a source of heat, a round bottom flask supported by a retort stand with clamp, a Thistle funnel and a delivery tube fitted in the round bottom flask, a Wolf bottle containing water as the purifying agent, a conical flask containing conch tetraoxosulfate 6 acid, and a gas jar where the dry chlorine gas is collected. Black granules of manganese 4 oxide are placed in a round-bottomed flask, and moderately concentrated hydrochloric acid is added through the Thistle funnel. The mixture is then heated gently. As the black oxide dissolves in the acid, there is effervescence. The gas liberated is greenish yellow. It is passed through water to absorb hydrogen chloride gas, which is also liberated at the same time, and then through concentrated tetraoxosulfate 6 acid to dry the gas. The gas is then collected by downward delivery, being heavier than air. In the equation of reaction, we have 1 mole of manganese 4 oxide reacting with 4 moles of hydrochloric acid to give 1 mole of manganese 4 chloride with 2 moles of water and 1 mole of chlorine gas. Industrial preparation of chlorine. Chlorine is produced industrially by the electrolysis of brine and the chlorides of molten sodium, magnesium, or calcium. The chlorine is then liquefied and stored under pressure in steel cylinders. Physical properties of chlorine. 1. Pure chlorine gas is a greenish yellow gas. 2. It is denser than air. Hence, it is collected by downward delivery or upward displacement of air. Number 3. It is moderately soluble in water. Number 4. The gas is poisonous. Hence, it is prepared in the fume cupboard. And 5. It can be liquefied easily under pressure. Chemical properties of chlorine. Number 1 is action on litmus. Chlorine gas turns moist blue litmus paper red and then bleaches it. Number 2 is displacement reaction. With the exception of fluorine, chlorine can displace any of the other halogens from solutions of their respective acids and salts. In the first equation, we have chlorine displacing bromine from a solution of its salt to give sodium chloride, and bromine. In the second equation, we have chlorine displacing iodine from its acid, which is hydrogen iodide, to give hydrogen chloride and iodine. Number 3 is direct combination with other elements. After this short break, we are going to continue from the reactions of chlorine. Welcome back. Number 3 reaction of chlorine is direct combination with other elements. A is with metals. Metals react readily with chlorine, especially when heated, to form the corresponding chlorides, as shown in the equation below. In the first equation, sodium metal combines with chlorine to give sodium chloride salt, and in the second equation, zinc metal combines with chlorine to give zinc chloride. B is combination with non-metals. Chlorine combines with hydrogen to give hydrogen chloride, and in the second equation, chlorine combines with phosphorus to give phosphorus pentachloride. Number 4 reaction of chlorine is oxidizing properties. Chlorine gas is an oxidizing agent. It oxidizes by gain of electrons or by removing elemental hydrogen from common reducing agents to produce hydrogen chloride, as shown in the equation below. In the first equation, chlorine removes elemental hydrogen from hydrogen sulfide to produce hydrogen chloride and a deposit of sulfur. In the second equation, chlorine oxidizes iron 2 chloride to give iron 3 chloride. Number 5 reaction of chlorine is the bleaching action of chlorine. Chlorine is a common bleaching agent. In the presence of water, it bleaches most dyes and inks. The bleaching action of chlorine is due to its ability to react with water to form hydrochloric acid and monooxochlorate 1 acid. Monooxochlorate 1 acid is unstable and decomposes to release its oxygen to the dye in the colored material to become white or bleached, as shown in the equation. We have oxochlorate 1 acid decomposing to give hydrochloric acid and oxygen. In the second equation, the oxygen evolved combines with the dye in the fabric to become white or bleached. Number 6 reaction of chlorine is reaction with alkalis. Chlorine reacts with aqueous potassium hydroxide or sodium hydroxide to produce 2 salts, depending on the concentration and temperature of the alkali. A. With a cold dilute potassium hydroxide or sodium hydroxide, the chloride and the monooxochlorate 1 salts are produced, as shown in the equation. Sodium hydroxide reacting with chlorine to produce sodium chloride, sodium oxochlorate 1, and water. B. With a hot concentrated potassium hydroxide or sodium hydroxide, the chloride and the trioxochlorate 5 salts are produced, as shown in the equation. We have potassium hydroxide reacting with chlorine to produce potassium chloride, potassium trioxychlorate 5, and water. Laboratory test for chlorine. Insert a strip of filter paper soaked in starch iodide solution into a gas jar or test tube of chlorine. The paper turns blue-black. Uses of chlorine. 1. It is used as a bleaching agent for cotton, linen, and wool pulp. Number 2. It is used as antiseptics, germicides, and disinfectants to destroy bacteria. Number 3. It is used in the production of hydrochloric acid. Number 4. In the purification of water supply. And number 5. In the chlorination of organic compounds. Revision exercise. 1. The elements listed below belong to the same group in the periodic table: fluorine, chlorine, bromine, and iodine. A. Write the electronic configuration of the first member. B. What is the family name of the elements? C. Which element has the strongest oxidizing ability? Number 2. Draw a label diagram for the preparation of dry sample of chlorine. And number 3. State the action of chlorine on moist blue litmus paper. Thank you for listening and stay safe.